morning everyone. Myself Ritu Singh, an assistant professor in Lakshmi Institute of Technology, Sarigam. Today I want to discuss the topic that is cement. We will talk, cement. So here we will talk about the not only the cement but its chemical composition, property, binding, everything we will see. So for the introduction, as we all know that cement is a building materials, is the ingredients of building materials. So it's a very popular because without cement we can't proceed further. It has having adhesive and cohesive properties. So what do you understand by adhesive and cohesive properties? Adhesion and cohesion. So if you go for the liquid and mercury is the best example for adhesion and cohesion. Mercury having attraction towards its own particles. So when you see the mercury in the thermometer, it does not get attracted to the glass, but it's attracted towards its own materials, and this having it's because of its cohesive properties. And adhesion is like water. When you fill glass with water, it get attracted towards the glass, not with its own materials. So the we come to the cement. That cement having both the properties, adhesion as well as cohesion. It attracts with the other particles like fine aggregate, coarse aggregate, water, and it get attracted towards its own particles also for the binding. So it binds the fine and coarse aggregate together to fill the voids in between fine and coarse aggregate particles form a compact mass. Now we will talk for the composition of the cement. So these are the composition of cement. Before going for the chemical composition, we should remember one note, that is saline. Best way to remember the composition of cement is saline. S for silica, that is SiO2 chemical formula. We have 20-25% in cement. A for aluminum oxide, it is having 4 to 8% in cement. Then L for lime, that is calcium oxide. It's having the maximum proportion in cement, that is 60-65%. And I for nothing but iron oxide or ferrous oxide we can call 2 to 4%, and magnesium oxide, that is 1 to 3%. So this composition you should always remember by the name saline. It's good to remember. Now cement, all we know that there are three kinds of mixture we can make with the help of the cement. That is, first is cement grout, a mixture of cement and water. Cement mortar, we are adding sand with cement and water to form a paste, and cement concrete, that composite products which is obtained by mixing of cement, water and inert matrix of sand and gravel or crushed stones. So cement grouts, for what we are using when we are having to fill some voids of existing structure, we are using the cement grout. Cement mortar, we all are knowing that we are using for the plastering purpose we are using cement mortar, and cement concrete for RCC work. Now cement, this is a Portland cement. Portland cement, earlier also I told you about the Portland cement, that before in the history only the name have been patent. So it's made by mixing substance like calcium carbonate, chalk and limestone with substance containing silica, alumina, iron oxide, as I have discussed before, that is saline. So clay shields containing silicon dioxide, ferrite, that is iron oxide, and aluminum, that is aluminum oxide. The chemical formula and abbreviation has given here. Limestone or chalk, as the chemical formula is CaCO3 calcium carbonate, and it is abbreviated as C. And this mixture, then the mixture heated and became one clinker. So the clinker then ground into powder. This is the methods we are preparing, in a short method we are preparing the cement, manufacturing of the cement. So this is all mixtures, these mixtures are heated and then form a clinker, and then they are converted into powder by grounding. Then the hardening Portland cement is a chemical process during which heat is evolved. So when we are adding water into it, it's going for the hydration and then it becomes hard. Now you may have the question why it is called Portland cement, not other cement. So Joseph Asprin and history, Joseph Asprin, an English mason who patented the product in 1824 and named as Portland cement because it produced a concrete that resembled the color of the natural limestone quarried on the island of Portland, a peninsula in the English Channel. So it one island called Portland, name of Portland, it resembled the color of that rock. So we are calling that Portland cement. Now this is very important chemical composition before we go for the type of the cement. So this is chemical composition of Portland cement. It is made up of 4 main compounds, that is tricalcium silicate, dicalcium silicate, tricalcium aluminate and tetracalcium aluminophride. So in the abbreviated notation different from the normal atomic symbol, these compounds are designated as C3S, C2S, C3A and C4AF. We can call for the abbreviation. C stands for calcium oxide, S for silica, A for alumina and F for iron oxide. Hydration of Portland cement. So while doing the hydration means while you are mixing the water with the cement, this chemical occur, and the following are the function of these chemicals during hydration. So this Portland cement is a hydraulic cement, hence derives its strength from chemical reaction between the cement and water, and this process is known as hydration. These 4 compounds, this cement consists of 4 compounds, that is tricalcium silicate, dicalcium, tricalcium aluminate, tetracalcium aluminophride and gypsum. The formula is given to you, that abbreviation is given to you. This chemical reaction we will discuss in detail. When water is added to cement, the following series of chemical reaction occur. The tricalcium aluminate reacts with the gypsum in the presence of water to produce ettringite and heat. This tricalcium aluminate plus gypsum plus water, ettringite plus heat. The formula is given here. This ettringite consists of long crystals that are only stable in a solution with gypsum. The compound does not contribute to the strength of cement glue. So these notes I have mentioned for your understanding what is ettringite. You may ask the question that what is ettringite. Ettringite is a hydrous calcium aluminate sulfate mineral. It is colorless to yellow mineral crystallizing in the trigonal system. So it's come in the chemical's name. Now we will go for the other compound, that is tricalcium silicate. We are also calling this alide. Is hydrated to produce calcium silicate hydrate, lime and heat. So formula is here, tricalcium silicate plus water, calcium silicate hydrate plus lime plus heat. So this CHSH formation has a short network fiber structure which contribute greatly to the initial strength to the cement glue. So once all the gypsum is used as per reaction, the ettringite become unstable and react with any remaining tricalcium aluminate to form monosulfate aluminate hydrate crystals. So this only you have to understand that when it react to what it forms. Now third is, that is dicalcium silicate, we are calling as belide, also hydrates to form calcium silicate hydrates and heat. So chemical formula is here. So this reaction contribute to the strength to the cement paste. This reaction generates less heat and proceed at a slower rate. So when elide form, that is dicalcium silicate, it when it is undergo hydration, the chemical reaction is produce less heat as compared to others, that is tricalcium silicate. So it is used for the other situation, like when we are preparing dam, then when mass of concrete is there. So if it liberates more heat, then we can't prepare it, and it have cracking due to more heat hydration. So, here we are using dicalcium silicate which produce less heat. So, this compound is however responsible for the long term strength of Portland cement, and it have the merits that it have long term strength of Portland cement. The ferrite undergoes two progressive reaction with the gypsum. In the first of the reaction, the enteric react with the gypsum and water to form enteric lime plus aluminum hydroxide chemical reaction you can see. So, this forms one garnets. The ferrite further reacts with the enteric forms above to produce garnet, that is ferrite plus enteric plus lime plus water, that is garnet. So, this clinker. The garnets only takes up space and do not in any way contribute to the strength of the cement paste. So, this you must know for the hydration of the cement. So, the hardened cement paste containing these followings chemicals, that is enteric 15 to 20%, calcium silicate hydrate CSH 50 to 60%, calcium hydroxide lime 20 to 25%, and voids 5 to 6% in the form of capillary voids and trapped and entrained air. So, when you go for the composition of cement, you learn this ratio, and when you go for the chemical composition of the cement, you should know this value. So, conclusion here becomes that it is seen that each of the compounds in cement has a role to play in the hydration process. By changing the proportion of each of the constituents compound in the cement and other factors such as grain size, it is possible to make different to suit several construction need and environment. So, this all proportion, if we variate, like if we variate the proportion, if we variate the percentage, then we can use for the different purpose. So, this we will understand while we will talk for the type of the cement, the roles of this all chemical composition. So, types of cement, depending upon our requirement, using it as suitable place, we use different types of cement. So, rapid hardening, first is rapid hardening or high early strength cement, quick setting cement, high alumina cement, Portland slag cement, low heat cement, air entraining cement, white cement, colored cement, Portland pozzolana cement. This all we will explain in details. Rapid hardening cement. So, this cement gets same strength as that of OPC. What is OPC? Ordinary Portland cement. It is the initial and final setting time as same as OPC, but it contains more tricalcium silicate and more finely grounded, means fineness is more than other cement. So, it gives out more heat, while fineness is more, specific surface area is more, then it gives more heat while hydration, and while setting, so it is such as unsuitable for massive concrete. So, it is used for the structure such as subjected to load early, that is road or bridge, means we can not use the rapid hardening for the damp preparation. Go for the next is quick setting cement. Quick setting means it will set quickly. So, it set faster than ordinary Portland cement. Initial time and final setting time is also less, that is 5 minutes initial and final is 30 minutes. It required for making concrete, that is required to set early as for lying under water or running water. So, where we will use this cement in running water or in where we want fast load, like road also we can prepare. Then initial setting being very little, there is always a danger of concrete having undergone an initial setting. Thus, this type of cement is used more special cases. So, one demerit is also here, that when the initial setting is only 5 minutes, then we have to keen observer and use under special cases only, that if we want to construct any structure in the running water, then we can prefer this cement. High alumina cement, it is one type of cement when we are preparing by adding burning of bauxite ore and limestone in correct proportion and at high temperature, when the resulting product then ground finely. So, in high alumina cement we are using bauxite ore and limestone in correct proportion. It develops strength rapidly. Its strength we can develop rapidly. It is a black color and resists attacks of chemical such as sulfate and seawater. So, sulfate and seawater attacks we can resist to here. Its ultimate and the final set takes place immediately thereafter. So, most of the heat it gives in the first 10 hours as a result can be conveniently used in the freezing temperature. So, at ordinary temperature it is used in thin layers. So, when in the freezing temperature like in the cold country we can prefer this type of cement, and it is having the quality to resist the sulfate and attack and seawater. Portland slag cement, it is used for mixing clinker, gypsum and granulated slag in a proper proportion. So, if we talk for the Portland slag cement, we are using clinker we have already discussed, that is cement aggregate and water we are mixing, it forms one clinker. So, granulated slag in proper proportion. Then properties of this cement is very similar to that of OPC, which is under. It has lesser heat of hydration and has better resistance of soil, sulfate of alkali matter. So, it also resists sulfates. It is better resistance to acidic water. So, we can make a structure which is chemical industries, we have structure. So, we can prepare with the help of this cement. So, this type of cement is mostly used in marine works. Marine works means in front of sea water or beach area, we have to prepare the structure, we can use this type of cement. Low heat cement, the heat generated by cement while setting may cause the structure to crack in case of concrete. So, this heat generation is controlled by keeping the percentage of tricalcium silicate and that of tricalcium aluminate low. So, this point chemical composition we have already understood in the previous slides. So, these points we have to keep in mind that tricalcium silicate and tricalcium aluminate, we keep this proportion as low in low heat cement. So, its initial and final setting time are nearly same as that of OPC. So, it is not very suitable for ordinary structure because the use of cement will delay time of drying. So, you also need more curing. So, in the suitable structure, in ordinary structure we will not prefer this low heat cement because of this demerits. Air entraining agents is the OPC mixed with some air entraining agents. So, the common air entraining agents are oil, fats and fatty acids, etc. So, this air entraining agent, this OPC ordinary Portland cement, we are mixing with some air entraining agent. What is it, the air entraining agents? Oil, fats and fatty acids. This material have the property of entraining air in the form of air bubbles. So, these bubbles render the concrete to become more plastic, workable and more resistant to freezing. So, however, because of air entrainment, the strength of concrete reduces and thus the quantity of air so entrapped should not exceed 5%. So, the limitation is there for the air entrained. White cement. So, we rarely use white cement, and for the decoration purpose or interior we are using this cement. So, it is a cement of pure white color having some properties than those of ordinary Portland cement OPC. So, greyish color of cement is due to iron oxide. If it is greyish color, it have iron oxide content, while white cement manufactured from chalk and clay free from iron oxide. So, when we eliminate this iron oxide, we will get the white cement. It is having same properties as that OPC. So, oil fuel and not the coal is used for the burning of this cement. So, it is much costly than ordinary cement. Here we are using in the OPC, while manufacturing we are using the coal for the burning purpose, but here when we are preparing white cement we will use the oil fuel. So, it is become directly costly than OPC. Now, colored cement. Various colored cement are prepared when required in special cases. So, suitable pigments are added with OPC to get red or brown cement, but for other color 5 to 10% of desired pigments are grounded with white cement. So, pigments used should be chemically inert and also durable. So, they must not fade due to the effects of light, sun or weather. So, this colored cement what is compared with the white cement, we are adding color inside it and percentage defined that 5 to 10% we have to add, and it must be chemically inert, it should not react with the weather, rain or sun. So, it will not affect or fade. Now last is that Portland pozzolana cement. Portland pozzolana cement is produced by grinding. This cement is also called green cement. Why it is called green cement? We will learn that by grinding together Portland cement and pozzolana, the cement has properties similar to that of OPC, same properties as that of OPC, and can therefore be used for all general purpose. Portland pozzolana cement produces less heat of hydration and offer greater resistance to attack of aggressive water or sulfate bearing than OPC. So Portland pozzolana cement are particularly used in marine works. It takes a little longer to gain strength. Ultimate strength of this cement is more than OPC. So now we are using in generally in today we are preferring for the normal ordinary structure, we are going for the Portland pozzolana cement because of this pozzolanic materials inside this, and it's gain more strength. Ultimate strength is more than that of OPC.